Alright, this is Boolean expressions. This video is mainly going to cover the logic laws part. And I also had a summer school program on this, only for a week. So I can tell you from experience that this stuff is going to be a breeze. I mean, it's not too bad. Except for one last question at the end, which I'll talk about it later, but is a bit cringe. Anyway, first we got to talk about logical equivalence. And logical equivalence is if two statements have the same truth table, then they are said to be logically equivalent. Let's go into our first logic law. So if we negate a negation, then it just doesn't do anything. So if we have two not operations, then they kind of cancel out. And if you want to think about it in terms of English, I got this statement off of Wikipedia, but I thought it was kind of nice, so I just copied it here. It states that if a statement is true, then it is not the case that the statement is not true. So a statement being true corresponds to the right part, and then not the case that the statement is not true is this left part. And we show equivalence with the three lines, so it's different from equals, because equals is to do with numbers, I guess, I don't know. But yeah, in Boolean algebra, to show equivalence, we use the three straight lines. Anyway, on to the commutative law. So if we have P and Q, that's logically equivalent to Q and P. So the order of which are statements doesn't matter when we're talking about the and or operation. Now onto the associative law. This is kind of similar to the previous law, but in this case we're talking about groups of statements. So P and Q and R is the same as P and Q and R. So you can switch the brackets around as long as we have the same operation throughout the entire statement, or throughout the entire line, I guess, I don't know. And here's the truth table to show that they actually are logically equivalent. I have no idea where I got this from. I think it's just a random Google search, but yeah. Now onto the distributive law. This one isn't as intuitive as the previous ones, but all it states is that you can group the statement outside, which in this case is going to be P, with the ones in the brackets, right? And you group it with the operation outside and separate them with the operation inside. So it kind of goes like this. And you're just going to have to know this law whenever you're doing like questions where you have to simplify Boolean expressions. And here's the truth table. The truth table doesn't really help with intuitive understanding of like these laws, but it's just to show you that this law is in fact like true. And I'm pretty sure I also got this randomly on Google Images. Now onto De Morgan's law. So De Morgan's law just states that if you have a not on the outside of two statements, then you can distribute it. But it changes the operation inside. So the not goes onto the not P and then the not Q, but it changes the and to an or, and vice versa with the other operation. And here's the truth table for De Morgan's law. It's got these weird symbols because I got this off of Wikipedia and they use these weird symbols. But yeah, you can see how they're logically equivalent. If you want to understand this further though, there is a nice video by my favorite stats YouTuber. That guy carried me through further stats. And he uses it in terms of Venn diagrams. So it's not exactly linked with these logic laws, but it's kind of a nice visual representation of how De Morgan's law works. So I'll leave a link to that video in the description. Anyway, now on to some exam questions. So first of all, we need to simplify the expression here. So if you remember your laws, this looks similar to the distributive law. But in this case, we just have to work backwards. So this is going to be E, because there's E in both of these brackets. And we have the inside here, which is going to join them up. And F or G, because the one here is within inside the bracket. And that's just how you simplify it. Pretty simple, right? Now on to another exam question. We have a Boolean expression here, and they wanted to simplify this so that it does not include any negation. And you must explain which Boolean algebra rules you are using at each step. So, because we have a negation here that's acting on brackets, we can use De Morgan's law. So I'll just write DM, but you should probably say the full name. This is going to be not A or not B. And then because of the double negation law, this just turns into A or B. And there you go. That's another question done. So this last question is what I was referring to at the start, because going over the laws that we've already covered, we can't actually do this question fully. And the reason I went over just those laws was because in the specification, it says clearly that they want you to only learn these laws, right? And those are all the laws that I just went over, yeah? But for this question, you need to know other laws that are not, like, said in this spec. So it's like, what the heck, man? How was I meant to know this? Anyway, I mean, it does come from the sample paper, but still, like to me, that's just a bit cringe. Anyway, I'll go over these laws right now. So the two laws you need to know are the idempotent law and the absorption law. So with the idempotent law, if you just have two of the same statements connected with and or, then that's just the same as just the statement by itself. And then the absorption law is if you have a statement and A or B, like this, then that's just equal to A, and it works the same way if you reverse the operations. So now with those new laws, we can actually do this question. So I don't know, maybe it just comes with experience, but you have to notice that this, and this are kind of like chunks, right? And they're separated by an or here. So we can use our laws on this chunk and this chunk. So this is just the distributive law, which turns into, I'm only focusing on this one, the middle one right now. So this just turns into A and B, or A and C. And then this one, the third block here, is going to turn into B and B, or B and C. And this is all separated by two ors, so there's an A and B over here. So we can use the idempotent law on these two, which just turns into A and B. And then we can use the same law on this one as well. So this is going to be B, or B and C. And this we can use the absorption law on. So this turns into just B. So we have A and B, or A and C, or just B. And then if we rearrange this B into the front here, this is going to be B, or I'm going to switch these two around so you can see it more clearly, but this is going to be B and A, or A and C. And we can use the absorption law here again, so this will just turn into B, and then the final answer is just going to be B, or A and C. And then that's fully simplified.